Hi guys, my name is Sushil. I'm a technical trainer from NH classes, and today we are going to discuss about one of the feature of your Cisco ISE, that is TrustSec feature. So let's discuss about it. In TrustSec feature, we have total 5 characters that you should know. One is security group tag, another is security group ACL, also known as a SGACL, IP to security group mapping. We have TrustSec security group tag protocol called as a SXP protocol, and we have an encryption method called as an MACsec. This type of technology is basically used for micro segmentations. Here, where you can see here we have a user connected with the switch and it has to connect the server. So along with your .1x authentication or MAB authentication, there will be an additional tag given from the ISE, which is known as your security group tag, SGT tag. So here I can see a user having a tag of 5 and server having a tag of 4 or a 10. So along with your .1x authentication or a MAB authentication, whatever you'll be having, in that there will be an additional security group tag provided by the ISE, which helps you for the micro segmentation and the additional security to your communication. So let's see more about these details. Now here I have a security group tag. What is security group tag? It's a centralized policy management, distributed policy enforcement. It is used for micro segmentation, okay, and it provides you confidentiality and integrity encryption based on the MACsec, which is IEEE 802.1a standard. It provides you AES 128-bit of encryption. Okay. So wire rate hop by hop layer 2 encryption. It basically uses a technology for a communication called hop by hop, which is at layer 2 encryption. So let's understand what are the types of encryptions. So here we can see we have end-to-end type of end-to-end type of communication, point-to-point communication, hop by hop communication. So basically SZT uses or TrustSec uses hop by hop communication. Now you need to understand what is hop by hop communication. Before that, let's understand what is end-to-end communication. End-to-end indicates a communication happening between two applications, right? Let's say, for example, you have a applications called as a Skype. It uses a end-to-end communication, right? Maybe you and your friend is using Skype. It does not care in middle, okay, what the communication method is. Okay, it just considers that two ends are talking with one another. It's generally a layer 4 or a higher communication. Okay, so whenever you're using any kind of an application for end-to-end connectivity or a communication, such type of communication is called the end-to-end communication. Now we have point-to-point communication. What is point-to-point communication? The two devices with an IP address have a cable going straight from a device to another device. So if we have one device connected with the other device straight through an IP, through a cable, right? Such type of communication is basically called as a point-to-point communication. Here we can have examples like PP or DHLC. It's a legacy one, right? Now we have a new method of communicating. That's your hop-to-hop communication. Hop-to-hop indicates the flow of a communication that passes through multiple devices with an IP address, okay? And each genetically named as a hop. So when we have to communicate from one subnet to other subnet, we basically send our traffic to our hop. So from one hop to another hop, when we communicate based on the IP address, this type of communication is basically called as a hop to hop communication. Hop by hop indicates analyzing the data flow at layer 3, checking all the devices in the path. So this is the example that I had shown you in a previous picture. If you see the previous picture, let me just get into previous picture. Here, you can see we have a host over here, and this host wants to communicate the server. And in between, you can see multiple devices are there, like switch communicating with the router communicating through firewall again communicating via switch, right? So this is where the hop to hop communication comes into a picture. So this particular user via switch wants to communicate to the server, and in between we have the multiple devices. which routes your packet based on your IP address. This type of communication is basically called as your hop-to-hop communication, right? Now, you can understand what is SXP. So SXP is basically a scalable group tag exchange protocol. So the security group tag, which I had shown you like 4, 5, 6, or 10, whatever we had between the user and the server, the security group tag will be provided to users by the help of SXP protocol. So you need to enable this feature on the ISE, you need to enable this protocol on the ISE, and then it will be using SXP protocol for the security group tag providing for the users. Now, it uses a dynamic and static security group, okay, pushed by ISE. So you can have either a dynamic security group tag, or you can have the static security group tag, which you have to create on the ISE, and later that will be pushed by ISE to the user and the server. I mean, source and a destination that you want to communicate with. SXP is a control management mechanism or control plane mechanism to transport endpoints security group with IP address from one security group aware network to another SGT aware network. So basically, it's a protocol which is basically carrying your security group tag from one source to a destination, right? With the help of the IP address. Along with your IP address, there will be a security group tag as well. And it also uses the SGACL. So what is SGACL? It's an ACL with source and destination address replaced by your security group tag. So basically here, the ACLs will be replaced by your security group tag, and based on the tag, you guys will be getting access to source and destination. Such type of mechanism is basically called as your micro-segmentation. Now, you can see here security group tag used for grouping users, right? Endpoints and resources that should have a similar access control policy. So we need to create one group, and we need to create a group for, it could be for endpoints or could be for users, right? And we need to have similar type of control policy. Again, we need to have a security group tag. Along with the group, we need to push the tag, right? It's a unique security group number that's assigned to a security group. So either it's a user or the endpoint that will be provided with the security group number. That's a unique number, or depends on you. If you want to choose the number from your side, you can choose it yourself, or it could be dynamic also. Now, security group TrustSec capable devices. Now you see here TrustSec capable devices, network access devices that capable hardware and software wise of understanding the security group tags. So you need to have the devices that can understand your security group tags. Like we have the switches, they can understand. We have the routers, they can understand the security group tag. TrustSec SID device, network devices or network access device that authenticates directly against ISE and acts both as an authenticator and supplicant for network access devices. Now we have network device admission control. That's your NDAC, right? This is in a terminology TrustSec Cloud. Okay, so we are currently not using a TrustSec Cloud. We'll be using our ISE device for our practicals. Okay, in this cloud technology, we verify the credentials by the peer devices by using 802.1 or EFAST, or it could be upon authentication and authorization negotiates with IEEE 802.1 AE encryption method. And the communication is protected with you have a protected access credentials. That's a PAC. It's a unique shared credentials used to mutually authenticate client and the server. Now, these are the components which are used in the TrustSec components, guys. TrustSec micro-segmentation, you guys can see. So what is the Cisco TrustSec? Now, if you discuss about the Cisco TrustSec, it's basically the authentication. It's an endpoint authentication control. Uses authenticated devices authenticated to a TrustSec cloud via 802.1x. That's your .1x authentication. or easy connect or map or web auth etc. So basically endpoint can authenticate and can be controlled by TrustSec, okay, and the users can authenticate by the methods like 802.1x or easy connect or map authentication or web auth etc. Security group tag control list, okay, what does it do? Security group access control list, all right. So these are used for access and the permission based on security group tags, not based on IP address. If you remember in ISE, we used to, control the access earlier based on the ACLs, downloadable ACLs, DACLs, right? But here additionally, now we are going to have the security group tags, right? And we control the traffic based on the security group tags. That is basically called as a micro-segmentations. Okay, this simplifies a security policy and does not focus on IP address or a subnet, but security group tag. So totally controlled based on the security group tag. And earlier, as we discussed, Security Exchange Protocol, SXP Protocol, okay, a service that uses to propagate IP to security group binding across the network devices that does not support SGTs. And this security group tag is basically called as an environmental data, right? And this environmental data will be present inside your ISE. So if you want the custom security group tags to be created, you have to create it on the ISE and later it can be downloaded on your switch through which you will be authenticating, which is also known as your NAT device. So download from the ISE to a network access device, which is your NAT device, as I told you, switch where a client will be connecting for .1x authentication. Such devices are basically called as a NAT device. When it joins the trusted network, when it does this, it downloads the following. It downloads the environmental data like ISE server list, right? It can use the for future ISE radius authentication and authorizations, device security group tag, the network access device itself, right? Expired time, identity to port mapping, right? All these things are basically downloaded from the ISE to your NAT device. So switch defining the identity on the port and using this identity to look up the particular security group tag value from the ISE. So environmental data is nothing but it's a security group tag that you'll be defining on the ISE and will be downloaded on your NAT devices, right? Where you guys will be connecting to access your network. Now, when I talk about the network access or network administration, one of the method is deploying the .1x, right? So while doing our .1x authentications also, you guys will get the security group tag option. So while I talk about the .1x authentication, in our .1x authentication, we have three types of deployments. We have a monitor mode, low impact mode, and closed mode, right? In a monitor mode, we don't have any kind of a condition applied. We don't have a pre-auth over here. So what is unconditionally open, so I can get access. I don't have a pre-auth over here. But when it comes to low impact mode, we have a pre-auth ACLs. So first of all, we'll have some limitations, right? And we'll have a post-auth ACL. So with the limitations, we have to authenticate. So limited authentications only you can do or control you will have. And the full access you guys will be getting only after authentication and the authorization. And closed mode is all about only if protocol is allowed for the authentication request from the user. And once you get authenticated, after that you have access to the given networks. So these are the three modes of your .1x authentication. And all these modes can be used for your micro segmentation in the network. Now, further, you can see ICE can be integrated with the DNAC to put all these security group tags or the micro segmentation. So that's our next plan wherein I'll show you how would you integrate the DNAC with the ICE. But while integrating a DNAC with the ICE or ICE integrating with the DNAC, you will need a few prerequisites. So integration prerequisites are there. First of all, versions should be compatible, okay? If it is not compatible, you can download the patch files and make it compatible with each other. SSH should be enabled on the ISE PAN, and the default port number should be 22. Okay. After that, we should have the credentials used to be the same for ICLI and GUI. You should not have a different credentials on the ISE for CLI and the GUI. Okay, it should have a admin rights with super admin right. PX grid feature should be enabled on the ISE, because PX grid is the feature which basically helps you to integrate and also to share the context between the ISE and the DNAC and ERS. Okay, that's your external REST system. Read or write should be enabled on the ISE so that a DNAC will get integrated. If this particular feature is not enabled on a DNAC, your integration will not happen. And after that, you can see once the integration, all the prerequisites are done between them, then you can integrate. You have to do authentication and authorization of a DNAC on the ISE. It would be based on the router IP address, shared secret key, right? And we can manage all the users connecting via ISE, right? We can push all the policies, right? So you can see here, we have a user connecting to NAT devices, right? And your Cisco DNACs will be integrated with your Cisco ISE, right? And further through the Cisco ISE also, we can push the policies, we can deploy it to all the NAT devices, and the users can authenticate accordingly. So all this type of, labs will be seeing soon. So the next video I'll be creating for Cisco ISE and DNAC integration. And also later we'll see the micro-segmentation deployment lab as well. That's it for today. Thank you guys. See you in the next video. Thanks.